In the previous video, I introduced you to the fourth of the four forces that come up over and over in this course, namely the frictional force. The frictional force is a force which acts parallel to the surface exerting it. The frictional force will always be directed so as to oppose sliding motion between two objects with surfaces in contact. Now, in this video, I'm going to show you that we can make a distinction between two flavors of friction. We have what's called kinetic friction. Kinetic friction acts in a situation where there is already a sliding motion in progress. In a situation where there is already a sliding motion in progress, kinetic friction acts to oppose that existing sliding motion. On the other hand, we have static friction. Static friction acts in a situation where the sliding motion has not yet begun. Static friction tries to keep that sliding motion from ever getting started in the first place. So I'm going to show you a couple examples. So let's just start by taking the air puck and give the air puck a push. And you can see that after I released the air puck, it slowed and came to rest. Why was that? It is because the tabletop was exerting a frictional force on the air puck opposite its motion. Now, was that frictional force that opposed the motion of the air puck and brought it to rest? Was that a static friction force or a kinetic friction force? Well, in this case, our frictional force opposed an existing sliding motion. A frictional force which opposes an existing sliding motion is a kinetic frictional force. So in this case, we have kinetic friction acting. On the other hand, let's say I have this box here, and I'm pulling on this string that's attached to the box. And we might expect that if I'm pulling on this string, the string's attached to the box, there's tension in the string. We might expect that the box would start sliding along the table, but it doesn't. Why not? It is because this pull of tension on the box is being canceled by a frictional force pointing the other way. Now, this frictional force pointing the other way to oppose the pull of tension, is that a static friction force or a kinetic friction force? Well, in this case, the frictional force is acting to keep that sliding motion from ever getting started in the first place. So when we have a frictional force which acts to keep the sliding motion from ever getting started in the first place, we call that a static frictional force. Okay, so recap. With the air puck sliding along the table, it is a kinetic friction force which acts opposite the motion to bring the air puck to rest. In this case here, where you have tension pulling on the box, but the box doesn't move, it is because a static friction force is opposing the tension. The static friction force is keeping that sliding motion from ever getting started in the first place.